So good morning. So welcome to CADVision System Webinar session. So today we will talk about what you didn't know about assembly and mating. So today I'm your presenter. My name is Ray. So obviously today we'll focus on some tools or simulations about the assemblies. So I will run through a few examples of the assemblies, what mate we have, what type of mating we can do, and then I'll give you some quick example as well. Maybe it's not a demo, it's a quick example to show you what can we do to make you give a clearer view of how our SolidWorks tool can be done. Okay. So in this webinar session, we will demonstrate how to bring SolidWorks tool into the assemblies and mating process. So this is great for users that do a lot of assemblies with different type of assemblies like mechanical mates, advanced mates. How do we apply into our workflow and things? So today what we will talk about today. Okay. So for today's sections, basically there are a lot of new things in 2015. If you are using SolidWorks 2012 or 2013, I think some of these mates maybe you haven't seen before, because some of it is new for 2014 and 2015. Okay. So for today's agenda, basically you look through mirroring, how we mirror assembly components, and then we talk about some assembly patternings. Okay, and we will go through the advanced mates, because I guess advanced mate, we have a lot of different type of mates, but we don't fully utilize all the mates. And then we have to go through mechanical mate as well. And then exporter views, I guess everyone is quite familiar with exporter view. So basically I will just roughly bring through the exporter views. And then we also got assembly visualizations, which can summarize your assemblies. Okay, and also interference detection, also a quite familiar features. I guess most of people use this before. Interference detection, which is to check the interference in between components to components. Okay, so first one. So first one we talk about mirroring. So mirror, I guess everyone know about mirror. Mirror is we mirror a components or some features, bodies through a plane. Okay, but this is a mirror components, so we mirror components. So when we mirror components, we can preserve the mates and also the motions. So when you mirror something, so there are 4 choices of orientations of the original part. So you also can select to create an opposite hand versions from the within assemblies. So when you mirror components, you may also create a new configurations in existing parts. You may also create a new part as well. Right? So you see, this is the 4 orientations that you can see here. Okay, and over here, this is the properties managers for the mirrors. So I will show you some of the examples. Okay, for examples, so if I wish to mirror these components to another side, what I will just use the mirror components, and then just select the planes, which plane you want to do the mirrors. Okay, perhaps I will use the front planes, and then the components to mirrors, I'll just select these tips. Okay, so I said we have 4 orientations. You can see here your 4 orientations. You can just select which orientation that you desire to get. Okay, or if you wish to copy it out in the opposite side, you can use this create opposite hand versions. By simply clicking this, you can create the tips from the opposite hand versions. Okay, so this I guess this is some very easy examples to talk about mirrors. Okay, so next one. So We also have some, next thing is talking about is assembly patterns. So you can pattern components based on hole results or pattern features in other components. So pattern in your assemblies, you update automatically if the seed feature changes. So new in 2014, you can do curve and sketch driven patterns in assemblies. Okay, they're only available in parts until 2014. So in 2013, you can do that, 2012 as well. So in 2014, features driven pattern is not called pattern driven patterns. So which means any type of patterns can be used as a seed. You can use pattern assist in your patterns or pattern assist in your assemblies. Okay. So this one, I don't have any examples for this. Next one. So next one, we're going to talk about the change pattern. And later we talk about some belt change features. So this is two different things. One is called change pattern. Another one is belt or chain. This is two different things. So change patterns is something new in 2015, while the belt or change features is the older one. So change pattern is basically we create patterns components grouped along a sketch or curved path that simulate a chain. So we can create a chain like this one by using the chain patterns. Okay. So you can, one or more components are attached to path and instance are created based on the path. So you create a path and then with one components you may pattern all this chain out. Okay. So I'll show you some quick examples of the chain pattern. So chain patterns and this one. Yep. So this is a chain pattern example. Okay. So as you can see here, we got one change pattern. If I go to edit features, so over here, we can just select what components, what's a chain path. We select the chain path, and then how many instances, how many elements we want to copy pattern out, and then also we can select the components group 1. Okay. And also the path links 1, path link 2, same goes to the change group 2. Okay. So and then in top there, you may select 3 different type of pitch methods. So for distance is to lock a single point to a path. So instance is separated by certain distance. While the second one is the distance linkage. So basically you lock 2 points to the path. So the instance will separate by certain distance. Okay. In this case, we are using the third one, which is called a connected linkage. Basically, this will lock 2 points to the path. Then the instance will basically be linked together. So as you can see here, everything is linked together. Okay. So this is how, what's the way that we can create the change. So what we need to do is just create the one of it. Okay. And the inside one, by just selecting both of it and select the path, basically SolidWorks will help you pattern everything out based on the pitch methods that you selected. Okay. Okay. So next one I'm going to talk about the next one is about the belt or change features. So belt or change features basically it doesn't give you the whole change. It doesn't create a whole change, but it will create a virtual belt path. Okay, you create a virtual path which attach and rotate in the cylinder face based on cylinder face. So the belt or assembly features it basically will add appropriate mates and relations to achieve the desired rotational result. Okay. And so you also give the option to create a new path on the feature as well. And then with this, by using this belt or change features, you can create a sketch like this one. You can create a sketch As you can see from this yellow line here, you can create a sketch. By using this sketch, you also may perform the sweep features. Okay. So let's see, as you see at this bottom here, what you can see is the features. We use the belt or change features, and then once we apply it, you will get a yellow line, something like that. So basically, this is the belt. This is the belt. Same as this example as well. You may see the virtual path. Okay. So we will look at some examples. Alright, so as you can see here, you can see there's a path here. So basically this is the sketch. After we create the belt or change features, and then you give you a sketch here, but it doesn't give you the chain or the belt. Physical change of belt by using this belt or change features, unless you are using just now what we talked about, the change patterns, you can able to create a physical change. But over here, we're only able to get a sketch. Okay, so have a look. How do we do this? Okay, basically, as you can see over here, we have 3 pulleys. The first one, the second one, and the third one. Okay, so the first one, in this belt members box, you will select the first pulley, and then the second one, you'll be selecting this one. Lastly, the third one, you select the bottom ones. So all these pulleys you have to select by following the arrangements. You have to select the first one, the second one, and third one. You couldn't select the first one, jump to the third ones, and go back to the second ones. So basically, it will give you some arrow. You will select based on the orientations, like the first one, the second one, the third one. So do not select 1, 3, 2. So select 1, 2, 3. Okay, and then over here you can select the diameters of the selected pulleys. If you select over here the first one, you may define the diameters of the pulley. Second one you may define as well. Third one you may define over here. Okay. Other than that, you may also select the belt length, whether it's driving, and then select the length of the belt. The length of the belt. You may also define the belt thickness as well. For example, over here is 15 millimeters. We are changing to 30 millimeters. You're able to see that a virtual path will show that it's thicker, it's 30 millimeters. But at the end of the day, it just gives you a sketch. It doesn't give you a real belt or change. So by using this path, you may also perform like sweep features to create a belt or change. Okay, close this. Back to the slide. Okay. So next thing, I'm going to talk about assembly visualizations. I doesn't know many people is there many people are doing this. So by using these assemblies visualizations, actually it will provide you a different ways to display and show and assemblies components. Okay. So as you can see here, by using these assemblies visualizations, you see right over at this picture right here, we can see the sustainability data. For example, we can see the carbon footprint, the energy use, water pollutions, and then you'll be able to see physical properties, the mass, volume, and densities. You see over here, we're currently showing the mass. Okay, so over here is what's the components inside the assemblies, and this is the quantities of components inside the assemblies, and basically this is the mass of the assemblies. I guess everyone quite familiar with the mass properties. If you select the mass properties, you can see the total mass of the whole components. But by using these assembly visualizations, what you can see is that the mass in each components is showing the mass in each components. So basically, it gives you a clearer understanding about your assembly design. Okay. Other than that, you're also able to see the assembly info, for example, the flexible sub-assemblies, and also the performance data. You may be able to see the review time for each components, and also the graphic triangles. Okay. So you can sort the list by using the basic numerical data. Okay. And then you may also like sort it by using custom properties, like create formula with custom properties, or group the components with identical components. Right. So we will look at some example as well. Examples, assembly visualizations. Okay, so basically what I'm opening now is a grill. Let me show this. This state. Yep. So I'm showing here is a whole grill assemblies. So basically is a Weber. We call it Weber. We use it to do something like barbecues, but this is quite commonly used in like Western country. Okay, so I'm going to show you some like assemblies visualizations. Okay. Okay. So by using assembly visualizations, you can go to the assembly visualizations, evaluate. Yeah, so it's in evaluate. Just go and select the assembly visualizations. Okay, so once you select that, you're able to see the color bar right here. Okay, so this color bar can be changed. Okay, so currently what I'm showing right here is the mass. Okay, this you can be changed by just simply clicking here to see what's the information that you want to show. For example, here I'm just showing the mass. Okay, so you're able to see the one with the highest mass. You see it's a tank, which is the red colors. You can see in this graphic area, you're able to see these red color tanks. So which means in the whole assembly, this is the highest mass. This contains the highest mass. As you can see, this weight about 15,694 grams. And then you're also able to change the color bar by changing the color to the color that you want. And then we also in here also give us the freeze bar. You're able to drag it back to show the components one by one. For example, I just drag it back here. I'm able to see these components, the highest mass, and one by one go down, something like that. Okay, so I just put everything down. Okay, and then you're also able to see the different view. Like just now what we're seeing, one is each components. So over here, if you select this flat or nested view, you're able to see in like different in the sub assemblies. You're able to see the assembly, the sub assemblies, something like that. And then you also can, if you're also able to group and ungroup the components. So you get to ungroup components. Okay. So other than that, other than showing the mass, you may show the density as well. Like simply clicking the assemblies, you will see the assemblies right here. So with the highest density, you see is the hex flank. Other than that, you may also see the surface areas. It's quite a lot of things to show right here. Like there's a lot of options you can play with, the styles, the value bar, what type of information you want to see. So basically you can see from here. So other than, so this basically is something we can have a better understanding about this assembly design. Rather than we just use the mass properties, we only able to see total volume or total mass. So by using the assembly as visualizations, it gives you a more clearer understanding about each component. Okay, so let me close this. Okay, after we're done with these assembly visualizations, next one we're going to talk about something that we commonly use. Okay, so which is the first one I will talk about the advanced meats. So in the advanced meat, the most commonly used one is the width meats. I guess everyone's quite familiar with the width meat. But other than that, basically we actually have a lot of other meats, but we don't really using it. Okay. So for example, we have limit distance. So we're able to allow the components to limit a range of linear motions. And also we have like limit angles, width positions. I guess you all know this. We also have symmetric path and also profile center meat. Okay, here actually, this if you can see in this picture right here, we open the advanced meat, expand the advanced meat, able to see symmetric path, everything right here. Okay. So same things, we will look at some examples of some of it. So okay, let me show you some examples. I guess we only have the profile centers because I guess others is quite direct. Just select the distance to limit or select the angle to limit. It's quite common. Same goes to with symmetric path. So I'll talk about today. I'm only showing about the profile center meat. Okay, profile center meat. Okay, profile center basically is to center one component's face on another component face. So you can use this like with like circular face. Same goes to you can use it on rectangular face as well. As you can see here, these components, you got one cylinders, one flat plate, and another flat plate. So we got one cylinder and two square, one square and one rectangles. So we want to place everything in the centers. Okay, we want to say the centers. So what we can use, basically, other than using the profile center meat, you may also use like coincidence or use width meats and a lot of different meats to add together to become one, something like that. But instead of using so many meats, we can also use the profile center meats. Okay. So for examples, I want to do this plate, place in the center, exactly the center of this plate. So I basically just select the two face and just use a profile center meats, and then you're able to see that it goes to the centers. Okay. You may also change the alignments. And also able to change the distance. If you don't want to be exactly the centers. Okay. So same goes to this is the rectangular to the square face. So same goes to the circular and the square face as well. So you may also use the profile center meat to select the two face, and then just perform the same options. You may also change this, just perform the same things, and then you will get it exactly in the meters. You get exactly in meters. So same goes to this as well. Okay. Let me close this. Yep, so other than that, if you can see in this mate, we also got symmetric mates, width mate, path mates. If you wish to know more about this, you may email to me. I will just give you a step-by-step guide on how to use all these mates. Okay. Okay, so next one I will be talking about mechanical mates. I don't know, is it many people, you guys are frequently use mechanical mates. So mechanical mates basically we use it when we want to mate something like gear or slots or some rack and pinions. So these are all the mechanical mate we can use. Basically, these are most widely used in like the machines, in the industry they're making machines. So you can see here we got gear. So by using a gear, so we can force two components to rotate relative to one another. Okay. So the rotation basically is controlled by using the ratios, and this also can be reversed to represent the pulley. Okay. Other than gear mate, we also have the rack and pinions. Basically, we got one pinions which is something like gear, and the rack which is a straight one with the T. Okay. So we can do a linear transitions of one part, which is the racks, okay, and cause the circular rotation in other parts, which is the pinions. Okay. And then we also have a hinge. So we can select the hinge by just simulate the hinge by using a concentric mate, coincident mates, and angle mate with mates. Basically, this you can be done by using 3 different mates. Just add in the concentric, coincidence, and angle mates, which you can done by using the standard mates. But instead of that, we can just use a hinge mate. So in this hinge mate, it contains these 3 mates together. So we doesn't have to add in one by ourselves. Okay. So you also have a cam mate. So a cam mate actually forms a cylinders, planes, or points of a follower components to remain coincidence or tangents to a series of tangents extruded base of a cam components. So same thing, it seems like the hinge. Basically all of these, some of it is just you can done it by using the standard mates, same like the cam as well. You can also put in the like coincident mates and add some tangents. Basically you get something similar with the cam mates. So all this can be done by using the standard mates, but we can just straight away add in by using the mechanical mates. Other than that, we also have the screw mates. So screw mate is basically we add a relationship between the two cylinder face. I can set the, for example, if I screw into one hole, I can set a screw mate. So I can set the revolutions. I'm also able to set the distance. When I turn the screw one round, how many revolution it will give to the other components. After one round, what's the distance we push the other components to the front. So basically this is the screw mate. And then we also have a slot mate. So slot mate basically something in 214 when you have it. So by using a slot mate, basically we can create a mate in between the slot and the components. So we can do a slot mate for like just a normal slot, which have a two side have the circular arc. But let's say if you have a slot in one side is a square and another side is a circular arc. So in that kind of slot, we couldn't do by using these slot mates. And also if the slot you are creating by using the splines, so basically your slot have a curvy ones. Currently SolidWorks we couldn't do yet. We couldn't do that. Okay. So let's see. So we give you some examples. So we look at some rack and pinions. Okay. So this is the rack and pinion mates. So as you can see here, we got one pinion here and the rack at the bottom. Okay. So after we put in all others mates, and then there's a rack and pinion mates here. So it's quite direct. Once you open the rack and pinion mates, first one, it asks you to select the rack. You may just select the edge over here, and then just select the pinions. Select the circular face, and then you define it as a pinions. Okay, so just select the rack and pinions. You may define it by using the rack and pitch diameters, or rack travels, or per revolutions. It's not many options. It's just for you to determine the diameters and the revolutions. Okay. So once you define that, if I roll over this thing, so as you can see, the rack will move as well. Okay. But the rack will go over. Okay. And then the T and the rack, the positions, you have to position it by using like concentrates, coincidence, and distance. This one you have to be like position by yourself. If you didn't position it, it may just have interference between each others. But you're still able to roll over, but you have like collisions. Okay, let me close this. Go back this one. Okay, so other than the rack and pinions, we also have a slot mate. As you can see here, like this type of slot, which has two circular arcs. So you're able to just define it. So just define the contact face between the slot and, for example, at this circular face. Just select this circular face and also the one of the face of the slot. Okay. You may also set it center in slot, or whether it's free to move in between the slots, or you can set the distance along the slots, how many can you move, and so the percentage can you move along the slots. So this is some option you can play with. Okay. So if as I said, if your slot is like you create it by using splines, you're also unable to perform this slot mates. Okay. So once you create a slot, if you put a free, so you basically get something like that. So you can go over the slot. You may also set a distance to not let it go too far away to the end. Okay. So we got this slot mate, and then we also got this cam mate. So for the cam mate, you will have this cam and this roller right here. So to perform this cam mate, what we need to do is you have basically to select all of this face, all of the face for this cam. Okay, let's select all of this cam. You need to select all this face. If you miss out one, so it doesn't perform properly, what you can do is just use select tangency. If you're lazy to select one by one, you can just select tangency by just simply clicking one of these surface and just press the tangency. So the SolidWorks will automatically select all the surface over here. Okay, and then just select the cam follower, which is this roller. Okay, and then you just select the cam mate. Okay, and then as you can see here, once you select the cam mate, you can see this thing. You roll by following the cam. Okay. So let me close this thing. So now we cam meets. Okay, so we will talk about some screw meet as well. The screw meet is this sliding job, not this assemblies. Yep. Okay, so over here, this basically is a screw, and it connects to these components. So I want to, when I turn these components, so this thing will go further, like a fixture to clean some things. So I roll this thing, as you can see here, I roll this thing. So that components you go towards to another plate to clean a thing. Okay. So all this thing you can be done by using the screw mates. So if you can see over here, I use a screw mate. I just define this cylinder face and this cylinder face. Okay, so I give a screw in between this cylinder face and this cylinder face. Okay, and over here I just put like normal mate, like coincidence and also concentrics, just to attach them together. And over here I just define a screw mates in these two faces. Okay, so I can just select the screw mates. You may also select the revolutions per millimeters. For example, if I select 0.5, so as you can see here, if I select 0.5, one round it will give you a more distance. So let's select 0.1. After one round, you go a lot further, go a lot faster. So you're also able to select distance per revolutions. So one revolution gives you 10 millimeters. Okay. So all this you can just tune with it, and then you're able to get it done properly. But same thing, SolidWorks will just in CAD model, SolidWorks will just go over. To really go over, the only thing you can do is by using motion analysis, you can prevent it to go over to other components. Okay, so basically this is the screw mate. Okay, so we're done with the screw mate. So that's why we talk about like exploited view. Okay, so exploited view is for us to more understanding about our assemblies. For example, in your assemblies you have like hundreds of components. How do you know how everything is they assembly together? How everything disassembles? So what we can do, we can use this exploited view. Okay, so when you see exploited view, you can create different configurations of different exploited view. So you can just create like configurations, different type of configuration. You can save different type of exploited views. Other than export one component, you may also export different components, different few components by just one step, one simple spool. Okay. So here I will show you some examples about the exported view. This one. We look for the file. Yep. Okay. So we do some exporter view for these components. So this is the configuration you can save in. You can save in like different type of exporter view. Different type of exporter view. And also the different positions of the configuration you may set in right here. For example, this is a closed arm. You may also set an open arm. So this is the configurations. You may also do some modification, got more hole here or lesser hole or bigger arm here. All this you can save in the configurations. But today we're not talking about the configurations, we are talking about the exporter views. So exporter view, you can basically go to the assemblies and just select the exporter views. Okay. So over here, the exporter views, basically what you can do is just, all this is the exporter steps. So whenever you've done one exporter steps, everything will be recorded here. Over here, you may also select the components to perform the exported. Okay, for example, I select this tip right here. If I just simply dragging one of the axes, okay, so you record out one step, So it goes to here as well. Just drag it out, and then you record the second step. And then you may also pull this out. I may also pull this out. So basically, just select the components and pull everything out. So when you pull it out, every exporter view will be recorded in here. Okay. So I just give you show you a. Okay. So this is a exporter view that already done. Okay. You just drag everything out, drag it nicely to the position that you desire. Okay. So once you're done with all these things, once you exported out, so the next thing you're able to do is you can just run a animate. So with this animate files, you may save it down, but just save it in the AVI file. Okay, so you may send to your customers or some clients, so they're able to see how this assembly and disassembles. All this can be shown up. Okay. And also you may also see the export view, something like that. So with this exporter view, you're also able to create a drawing for it. So if you create a drawing by using exporter views, when you're doing the balloons, and also that balloon that related the link to the bill of materials, so the balloons will be like give you a more clearer view. So the balloon maybe you show number one is these pins, number two is this nut or washer, number three is this cowl, something like that. So it gives you a more clear view of the balloon when you're doing ballooning, instead of just doing a balloons in the components without exporter view. Okay, so let me close this one. Let me see. So basically, I guess that's the end of today. So exporter views. So if you have any other questions, or if you have any like problems that you couldn't solve, you wish to help, you want me to help you to solve it, or give you a guideline of how to use the mates, just drop me the emails, and you can also just let me know what's your problems, and I'll try to reply you within between one business days, and give you some examples how do we do the mates. Okay. Okay, just drop me an email. I will reply you whenever, as soon as possible. Okay, so my email is in here. Okay, and thank you everyone for attending for this webinar section. I hope everyone know more about the assemblies and mates. Alright, thank you.